Okay, properties of exponents. This is going to be kind of a review from Algebra 1 and may or may not have been using these properties already, but what this next unit is in Algebra 2 is we're going to apply all these properties just with different types of exponents. But anyways, multiplying or multiplication of exponents, I'm going to explain a lot of these with examples and then kind of go back and establish the rules. But let's say I've got x to the second power times x to the third power. Okay, x squared means I've got x multiplied by itself 2 times. X to the third is 3 of them. So if I multiply them together, I notice that I've got x to the fifth power. Now the shortcut to that would be that I can add the exponents up, take the 2 plus 3 to get 5. Okay, now this works if I have the same base and that I'm multiplying. I can add those exponents. Okay, I'm going to skip power of a power for a second. Dividing exponents. So let's say I got like x to the third power divided by x to the second power. So x to the third means x times x times x squared. Now if I go through and I cancel out an x from the top and the bottom, I'm left with 1s. If I do the same thing, I'm left with 1s and I'm left with an x on the top. Or I could take this exponent of 3 and 2, subtract them, and that's how I get x to the first. So when I'm dividing and they have the same base and divide, I get to subtract the exponents. And that's usually the case, that multiplication increases exponents or powers and dividing them decreases the powers most of the time. Okay, so power of a power, back to that one. That's where I get to take something and raise it to another power. Okay, so this outside means, this 3 means I'm going to take x squared and multiply it by itself 3 times. And using the rule from above, I can take the 2 plus the 2 plus the 2 to get 6. Or I could take this 2 times 3 to get x to the 6. So power of a power, I can multiply the exponents. So hopefully those are bringing it back. I'm going to double check real quick. Good, I do. Power of a product. So in other words, if I'm raising some two things, like say it's 5x to the third, raise to the second power, make sure that I raise the 5 to the second power and the x to the third to the second power. So 25x to the 6. Quotient just means if I've got something like x to the second power over 5 and I'm cubing it, I can take the numerator to the third power and the denominator. So to get x to the 6 over 125. Negative exponents, I call these the reciprocal powers. Reciprocal. Okay, that means to flip the fraction. So if I've got a negative exponent in the denominator, I'm going to flip the fraction around and make it a positive exponent. Or if I've got a negative exponent in the numerator, I'll flip the fraction around and make it a positive exponent. Okay. Anything to the 0 power, so literally anything is always 1. Now I say that the property is located on page 323 in your textbook, but you're not given a book, so they are commonly shown on Google. You can Google them whenever you want. Okay, so let's just run through some examples. So x to the fourth, x to the second, I'm multiplying, so there's that multiplication. These are the same base, so I'm going to add those up and get x to the 6th. Okay, power of a power, so I'm going to take x to the 3 times 2, so x to the 6 that way. Okay, 3x, it's both of them are in the parentheses, so I'm going to square both of them, so 3 squared and x squared, so 9x to the second. Okay, fractions, so I kind of like doing this. I would say that the top has more. So when I subtract these, 5 minus 2, so x to the 5 minus 2, when I'm done subtracting, that should be in the numerator. You don't have to write it with an over 1, but you can make it x to the third. Okay, x to the third gives me 3 minus 3, which is x to the 0, which is 1. Okay, so here, x to the 3 minus 5, that's going to give me x to the negative second. But because there are more on the bottom, I'm going to put that x to the second on the bottom. Now, I need that 1 on top, though, to make sure that stays as a fraction. Yeah. Kind of like this. If I go 10 divided by 2, it's 5, right? You can put it 5 over 1, but it's 5. 2 divided by 10, I know there's going to be a 5, but I need to keep the 1 to keep it a 1/5, keep it a fraction. Kind of the same thing in the last problem versus the number 4 versus number 6 up there. So this one's a whole number. I don't need the 1 underneath it. This one was a fraction, so I need the 1 on top. Okay, parentheses. How to read the parentheses, the importance of parentheses and things like that. So this first one over to the left right here, it's -5 times -5 because the -5 is in parentheses. It's positive 25. Believe it or not, the second one, the negative's not in the parentheses, so it's only the 5 being squared. So it's a negative 25. If you don't believe me, grab your calculator that uses parentheses, not your iPhone calculator, but an actual TI calculator. Put the parentheses in there, take them out, and see what happens. Like the second one here, it means I'm going to square both 4 and the x. So 4x times 4x, 16x squared. Okay, so if squared means to write this thing out twice, cubed means to write this out 3 times. And hopefully that's kind of fresh in your memory. We did that about, well, I guess it's about 3 months ago, 2 months ago. Okay. Here, everything is written to the 0 power. Everything, right? The parentheses includes everything. So this is 1. Here it's only x to the 0 power. So 5,280 times 1, my answer is 5,280. Okay, so again, importance of parentheses. Okay, I will have 3, 4 times 2, so 3 to the 8th. Big number, I don't have a calculator in front of me, but we can do that a little bit later if you like. Here, 5 over 8 raised to the 3rd power, so 5 to the 3rd over 8 to the 3rd. So that's 125. That's 64 times 8, so 2, 1, no, just 3, 48 plus 2, 5, 22, I believe. Okay. See, they're both negative 2s. I'm multiplying, so what I can do technically is add those exponents, make it negative 2 to the negative 3rd plus 9, so negative 2 to the 6th. Okay, so positive, I believe 64. And there you go. And if you're watching this, hopefully it's because you missed class. If not, we're going to go over this in class, and we're going to do a bunch more examples to hammer this stuff home.